Trigonometry, the study of triangles and the relationships between their sides and angles. In this video, we will look at how to find an unknown side in a non-right angle triangle using the sine rule. The sine rule works by providing two equal ratios that we can use to find an unknown side. The ratios are formed by using an angle matched with the side opposite. Here are the angles with their opposite sides. So we have the angle A opposite the side A, the angle B opposite the side B, and the angle C opposite the side C. Now for the sine rule, we need two ratios to build a solution. So we will require two pairs of opposites. So for the first example, we'll use the angle A opposite the side A with the angle B opposite the side B. So how will we use the sine rule to build a solution? So the sine rule states that for the two pairs of opposites, that the sine of the angle A over the side A equals the sine of the angle B over the side B. So what the sine rule does is it provides a way to form one ratio equal to another ratio, which is perfect for solving for unknown sides. Now you can also use another two pairs of opposite sides. You could use the angle A opposite the side A with the angle C opposite the side C. In that case, the sine rule will tell us that the ratio of the sine of the angle A over the side A equals the sine of the angle C over the side C. Or you could use the angle B with the side B and the angle C opposite the side C. The sine rule would then tell us that the sine of the angle B over the side B is the same ratio as the sine of the angle C over the side C. Okay, so the sine rule is all about providing one ratio equal to another ratio, equivalent ratios. Now the sine rule is in your log tables. So looking at your log tables, we can see here that we have the trigonometry of the triangle. And here we have the triangle set up the same way that we just did. So the angle A opposite the side A, angle B opposite the side B, and angle C opposite the side C. And one of the ways we can solve for unknown sides or angles is using the sine rule. You can see it written here. Now, do you see the way it's laid out here? It's with the three ratios equal to each other. Now, the one thing that's different in your log tables is that here it's represented with the side over the sine of the angle. So the angle on the bottom and the side on the top. Now, that is perfectly the same as the angle on the top and the side on the bottom. And it won't matter which one you use. Okay, so what this does is provide us with three more options. So we now can use that the side A over the sine of the angle A is the same ratio as the side B over the sine of the angle B. Or we can use that the side A over the sine of the angle A is the same ratio as the side C over the sine of the angle C. Or that the side B over the sine of the angle B is the same ratio as the side C over the sine of the angle C. And honestly, it won't matter which one you use. When I was in school, we always used this one where we put the angle on the top. But because it's represented with the side on the top in your log tables, and that's what you'll have in your exam, that means for the rest of the video, I will always use the representation with the side on the top. Now this is because when we solve two equivalent ratios, we are going to use cross multiplication as the easiest way to solve an equation derived from the sine rule. So the cross multiplication will mean it won't matter which representation we use. The only thing that is important is that if you put the side on the top of the ratio on the left, you must put the side on the top of the ratio on the right. So you must choose the same format, left and right. Now I will caveat all of this by saying that if you decide to use the balancing method for the whole solution instead of cross multiplying, it would certainly be easier to choose the ratio that leaves the unknown in the numerator, in other words, on top. So what that means is, just get rid of this, what that means is if I'm looking for a side, if it's an unknown side that I'm looking for, use this version here because that will leave the unknown on the top. But if you're looking for a missing angle, we will use this side here because that will leave the angle on the top, and that will certainly make it easier to solve if you're using the balancing method for the whole solution. Okay, so now let's do a question using the sine rule to find an unknown side in a non-right angle triangle. Example number 1. Find the length of the side A correct to 1 decimal place. So the first thing is, when you see a triangle, I want you to do a checklist. Okay, and that's because when you're in an exam, all triangles look the same. So you have to be very methodical about it. So looking at our checklist, the first thing we will ask, is it a right angle triangle? And if it is a right angle triangle, you will use sine, cosine, tan by labeling your triangle, or you will use Pythagoras theorem. If it's not a right angle triangle, is it a non-right angle triangle? And the first thing that you will think about is the sine rule and look for 2 pairs of opposite sides. And then there is another rule that we will be doing in the next video. Okay? Now, if you look at your log tables, that checklist is exactly what is here. Okay? That's why you should always have page 16 open in front of you when you're doing a trigonometry question. Even for your homework, okay, you need to get practice of always having that in front of you. So your first question is it a right angle triangle? And if it is, you can label it and use sine or cosine or tan, or you can use Pythagoras theorem if you have 2 sides and you're looking for a third side. Now, if it's not right angled, then you think, well, it's a non-right angle triangle, so my options are up here. My first option is my sine rule. Okay, so to identify whether you need to use the sine rule, you look for your 2 pairs of opposite sides. Okay, so that's what we're going to do now. So looking for our 2 pairs of opposites, we can see here that the side A is opposite the angle 80 degrees and the side 11 is opposite the angle 68 degrees. Okay, so we're going to use those 2 to build our solution. So go and check your sine rule in your log tables. This is what you would have open in front of you. And you would remind yourself there that it's the side over the sine of the angle equals the side over the sine of the angle. Use that to build your solution. So we have that the side A over the sine of 80 degrees equals the side 11 over the sine of 68 degrees. Now the easiest thing to do here when you have a ratio equal to a ratio is to cross multiply. So when we cross multiply, we have A multiplied by the sine of 68 degrees equals 11 multiplied by the sine of 80 degrees. And for your own convenience, try and leave the unknown on the left-hand side. Okay, then we're going to use the balancing method to finish off our solution. That's because here we can see that the A is multiplied by the sine of 68, but we only want to know what A is. So to reverse multiplying by the sine of 68, we're going to have to divide by the sine of 68, and we're going to have to do that on both sides. So on the left, that will cancel out my sine of 68 and leave me with the A that I'm looking for. And on the right hand side, it gives me 11 times sine 80 degrees divided by the sine of 68. And just leave it there in fraction or ratio form. Because what we're going to do now is put that straight into the calculator using our ratio button. So we press our ratio button, and on the top we have 11 times sine 80. Remember, you don't need to put in a multiplication sign, you just say 11 sine 80. The calculator understands you mean for that to be multiplied. Down arrow into your denominator, and then the sine of 68. End bracket and come out of your denominator equals. And we can see here our answer is 11.6836. Go back to your question. It's looking for A correct to 1 decimal place. So we will round that 6 up to a 7 because of this 8. So my answer is 11.7. Okay. Now, example number 2. Find the length of the side C correct to 2 decimal places. So first of all, let's look at our checklist. Is it a right-angled triangle? No, it's not. So is it a non-right angled triangle? Yes, it is. So the first thing I look for are two pairs of opposites to see if I can use the sine rule. So I see here that 12.8 is opposite 83 degrees and C is opposite 39 degrees. So I can use the sine rule now to build my solution. So check your sine rule in your logs. And we have that the sine rule is the side over the sine of the angle equals the side over the sine of the angle. Use that to build your solution. So we have the side C over the sine of 39 degrees equals 12.8 over the sine of 83 degrees. So the easiest thing to do now to solve this is to cross multiply. So I've C multiplied by the sine of 83 degrees equals 12.8 multiplied by the sine of 39 degrees. Use balancing to finish off your sum. So C is multiplied by the sine of 83. So to reverse that, divide by the sine of 83 on both sides. So that leaves me with the C I'm looking for on the left, and on the right 12.8 times the sine of 39 degrees divided by the sine of 83 degrees. And as I said, just leave it in its ratio form because we'll just put it straight into the calculator like that. So we have ratio 12.8 by the sine of 39, end bracket, arrow down to my denominator, which is the sine of 83, end bracket, come out of your denominator, which actually you don't always have to do, it still works, equals 8.1157. Check your question. It asked for C correct 2 decimal places. So after my 0.11, I've got a 5. So let's round up to 8.12. Okay, so the length of C is 8.12. Now, example number 3. Find the length of the side X, correct 2 decimal places. So let's look at our checklist. Is this a right-angled triangle? No. Is it non-right-angled? Yes, it is. So the first thing I check are, do I have two pairs of opposites? We can see here that X is opposite the angle 49 and 6.4 is opposite the angle 36 degrees. Okay, so now we know that the sine rule is appropriate to build a solution. So check the sine rule in your log tables. Okay, and it reminds us that the sine rule is that it's the side over the sine of the angle equals the side over the sine of the angle. So use that to build my solution. So I've X over the sine of 49 degrees equals 6.5 over the sine of 36 degrees. So cross multiply. So we've X multiplied by sine of 36 degrees equals 6.5 multiplied by the sine of 49 degrees. Use our balancing method to finish our solution. X is multiplied by the sine of 36. To reverse that, divide by the sine of 36. So that cancels it off on the left for me and leaves the X that I'm looking for. And on the right, I have 6.5 times the sine of 49 degrees divided by the sine of 36 degrees. As I said, leave it in your ratio form because it'll go straight into the calculator like that. So we have the ratio of 6.5 times the sine of 49, end bracket, arrow down to your denominator, put in the sine of 36, end bracket, out of your denominator, equals. So 8.3459. Check your question. We need to know X correct 2 decimal places. So after my 2 decimal places, 0.34, I have a 5. So let's round up to 0.35. So 8.35 is my answer. Okay. Now example number 4. Find the length of the side X, correct 1 decimal place. So why don't you pause and give this a go yourself? Okay, so let's answer it. So first thing, your checklist, is this a right angle triangle? No, it's not. So the first thing you do then is check, are there two pairs of opposites so you can use the sine rule. So here we can see that the Y is opposite the angle 30 and we have the side 16.4 is opposite the angle 110. So I have two pairs of opposites, which means my sine rule is perfect. Okay, so check your sine rule in your log tables and then build your solution. So my sine rule will tell me that the side y all over the sine of 30 degrees should be the same ratio as the side 16.4 all over the sine of 110 degrees. So here, first of all, I'm going to cross multiply. I'm going to keep my unknown on the left, so that's y multiplied by the sine of 110 degrees equals 16.4 times the sine of 30. Okay, from here on in then I'm going to use my balancing method because my y is multiplied by the sine of 110, so I'm going to divide both sides by the sine of 110 to reverse that. So divide by the sine of 110. Okay, so that will cancel this off for me here, and I'll be left with just the y that I'm looking for. And on the right hand side I have 16.4 times the sine of 30 all over the sine of 110. So there's my ratio. So let's use our ratio button and put that straight into our calculator. I have 16.4. The calculator knows you're multiplying, so sine of 30 and then down arrow, and then we've the sine of 110. So my answer is 8.726. Now I'm asked for correct one decimal place, so that will be 8.7. So y equals 8.7. Okay.